Hello everyone and welcome to possibly the most difficult video of them all. I keep on saying this, but this is going to be a very difficult video because recursion is a concept that's actually taught in APCSA level courses. So what is APCSA? It's actually a high school level course. And we're not going to be going like crazy in depth into recursion because it is a very difficult concept, but you'll see why recursion can be very helpful, especially in your text adventure game once you get started on that. You need to know some basic recursion because recursion is oh so very helpful, and you'll see why. Okay, but what is recursion? In this video, we're going to be going over a lot of code examples, and that's why I recommend you continuously pause your video to try to understand the code yourself before I go over it. So in this simple example, our goal is to print out the numbers from 1 through 5. If you look at the top example, of course you might want to use the top example over the bottom example, but we're going to show you an instance where maybe it's better to use the bottom example. And what I mean by that is, let's take a look. Top example, for I in range 5, print I plus 1. That will print 1, 2, 3, 4. Okay, maybe I should have done it in I in range 6. But you get the gist of it, right? It'll print out a number from 1 through a certain range. Let's take a look at the second picture. This is the recursive example. So we have our function header, go up, and we have two parameters, counter and max count. Think of this again as a simulation. This is our counter, our go up function. Every single time this function is called, we're first going to check if the counter is greater than max count. That means the counter went over, we are going to return. And we can, this is a cool thing, we don't have to return anything. Because look at our go up function call right here. We never save the value of anything, right? So this is something called a void function, right? You don't have to know the terminology yet, but basically this means that this function does not have a value. It does not need a response. The response can be empty because we're not using the response, right? And so when we say return, we're basically saying, okay, we're going to stop our recursive call. And think about recursive as recurse, right? We're calling the function over and over and over and over again until we reach a base case. And I'll show you what I mean by that in a bit. But anyways, if counter is greater than max count, we're going to break out of the function, or else we're going to print out the counter, and then we're going to call go up inside of go up. This is recursion, okay? So base case is how we can avoid the infinite recursion, right? And I'll show you again what I mean by that. Counter changes every recursive call. You see how every single time we call go up, our counter goes up by 1. But max count stays the same with each recursive call, right? And so there's a changing recursive variable, and there's a static recursive variable. So dynamic versus static, okay? And we'll talk a lot about these things, so don't worry. And then finally, of course, we have to initialize the recursive function with the first function called go up. Our 1 is our initial counter, and then we have to go up to 5. How will this look like? This can be very confusing, so let's trace this, right? Let's actually look at how this code works. So I have a text file right here, and basically I have a call and response, right? So I'm going to flip back and forth between these two. Hopefully that won't hurt your eyes, but let's move forward. So we call go up with our counter being 1. Of course, we print out 1 because, you know, counter is not greater than max count yet. Then we call, in the same function, we call go up to 5. When we call go up to 5, we're still going to check if the counter is greater than max count. It's not. So we print the counter again. And this time we print 2. Then we call go up 3, 5. We print 3. We call go up 4, 5. Then we print 4. We call go up 5, 5. We print out 5. We call go up 6, 5. 6 is in fact greater than the max count, and so we stop there. We don't print out 6, we just break out of the recursive function. So a recursive function is, again, calling the function over and over again until a certain condition is met. In this case, the condition is that the counter does not go over max count. When can this be useful? Well, let's take the case of user input, like the BuzzFeed quiz or the RNG game that we made, right? When we need to ask the user for something, let's say the user enters something stupid. How do we re-ask that question? Of course, we can use iteration. We can use a while loop. We can say, while the user does not answer anything stupid, ask the question, or while the user answers something sensible, ask the question and process the answer. But if the answer is stupid, we're going to continue with the while loop. If the answer is okay, then we're going to continue on with the code, right? So that's when it can be useful. And let's take a look at another example to see what I mean by this. If you're getting confused, don't worry. So we have the RNG game. On the right side is our recursive function. Don't analyze that yet, although you can if you want to. It's just the left side that I want you to analyze. When we made the RNG game, we didn't even know about loops. So let's analyze the left side, right, with iteration. So comp num equals random. We're going to generate our random number, and comp num is our variable for that. We also have to keep track of our number of guesses, and then we have max guesses, which is 3. And the reason why we have max guesses in capitalized, and this is the same thing over here, why we have max count capitalized, is because this stays the same during each iteration. And so we can indicate that with all caps lock. In the while true statement, of course, you have to check if the num guesses is equal to the max guesses. If we reach that point, too late, we have to print out the correct number and then we break. That's when they fail, right? If they don't fail, that means that we still have guesses left. We ask for their user input from 1 to 10. If the user input is greater than the computer number, we print too high. If it's less than the computer number, we print too low, or else we print correct. You got it in some number of guesses, and we break out again. And then every iteration that works, we're also going to increase the num guesses counter by 1 until we reach, that first statement where we say too late. This should be pretty easy to analyze, and analyzing code should be something that should become second nature to you. I don't expect it to be right now, but start getting to that point where it becomes second nature. The right side is the difficult part. First of all, I'm just going to say straight up that the right side is actually the better side. It's better, and I'll explain why, because it's more usable. And I'll show you a demo of what I mean by this, right? Let's take a look. So we have this RNG function, right? We have 4 variables. Comp num is, of course, the randomly generated number, okay? Max num is the maximum range, right? From 1 to x, right? It could be from 1 to 100, from 1 to 1000. Num guesses is, of course, the same as before, the number of guesses. And this is our dynamic variable. This will change within each recursion. And then max guesses is that static variable that never changes, and that is our threshold, right, of guesses. So, of course, at first, if num guesses is equal to max guesses, we print out too late the correct number was the computer number. But this time we return, because remember, return is the way to stop the recursion. It's not break, it's return. Then we ask the user input. If the user input is too great, we say too high. If the user input is too less, then we say too low. Or else, we print out correct, you got it in this number of tries, and we, again, return. We don't break. Now, this is the part that gets people confused. We are basically moving our function from one state to another. In this case, we're recalling the RNG function. So here you see how we increase num guesses by 1. But here we are actually increasing num guesses by 1, but also passing in these other parameters to the next function call. We are passing the state to the new recursive function. And we keep on passing this state until the very end, right? And so we passing the computer generated number, right? That won't change. Max number, that won't change this entire call. Num guesses is the dynamic variable, so this will change. And then max guesses will also not change. The only thing changing is num guesses, which goes all the way up until max guesses. So the most difficult part is the RNG function. This part right here. Because this is the recursive function that basically just does this. Num guesses plus equals 1. Why are we doing something this complicated? Well, of course, we have to pass in the same state, right? Our RNG function needs the computer number, the maximum number, the number of guesses, and max guesses. We know that in our function, the randomly generated computer number will stay the same. Max number will stay the same. Max guesses will stay the same. This will be the same for the entire game, right? Num guesses is the only thing that's changing. It's going to increase by 1 until we reach max guesses. Try to make sense of that, right? Very similar to the while true loop. It's a little bit more convoluted, but it's a lot more useful. Why is this? Let's actually take a look. Okay, so we're here. let's run the Python 3. This is using the shell, so you don't have to worry about this. RNG iterative.py. Enter number from 1 to 5. Too low, so 7. Too low, so 9. Too high, the correct number was 8. Oof. We can run it again, and it'll give us the same thing. From 1 through 10, we'll have 3 guesses, always. Okay, makes sense. 2, too low, 7. Okay, great. I got it in. I shouldn't say 1 try, I should say 2 tries. So perhaps we need to set them guesses to 1 at first. Okay, cool. So it looks like it's working as intended. Mostly the got it in 1 tries maybe needs to be fixed. Now what about the RNG recursive? Here are our function calls. This is what I didn't show you. And the reason I didn't show you this is because this is the cool part. If we wanted to make another version of the random number generator game, but with different parameters, right? Like for example, we wanted a random number generated from 1 to 100 this time, and we wanted the max guesses to be 7 this time, right? Or some other random rules that we wanted to change. We have parameters for that here to change that. So instead here, if we had to, for example, here we call the RNG function again, but this time we generate a random number from 1 to 100 with 100 as the max number. We start off with the counter of 0, and we have up to 7 tries this time. If we were to do that here, we would actually need to copy paste this entire thing. We couldn't just change one variable and say, hey, we're done. But here in our function, we only need 1 function. Let's say we wanted to create a new game again. And this time we wanted to do 1,000, right? This is the difficult, right? We have easy, and then we have medium, and then maybe difficult or hard, right? And this time we can change the parameters again. 1 to 1,000. 1,000 is the max, of course. 0 guesses, and this time only 12 guesses. Very, very difficult. Let's make it like 14. You can see now that with each of these function calls, we don't have to copy paste our code. We just have to change the parameters. This is what a simulation does, right? This is why functions are useful. This is why recursion is useful. You'll see another case of why recursion is useful in our calculator video, and it'll be much more simpler than this, trust me. This is a very difficult video, actually. Very difficult concept. This would actually be worth like 40 points on Challenge Fest, if you know what that is. But let's run this and see what happens. Python 3 RNG recursive.py. Number from 1 to 10. Great. Got it in 0 tries. Okay, again, probably I should call these functions with 1 instead of 0. So let's do that. Enter a number from 1 to 100. Or let me clear this again and let me. Okay, whatever. I'll just continue with the game. 50, too high. 25, too high. 12, too high. 6. Great. I got it in 4 tries. And then the 1,000 smackaroos. Too high. Can I get it? Let's see if I can get it. 500 is too high, so 250. Too high. 125. Too high. 75. Too high. 37. Too high? What? Okay. 18. Too low. Okay. 25. Too high. 20. Too low. 22. Too low. 23. Too low? Let's go. We got it in 11 tries. So yeah, as you can see, this is very cool. Allows you to make mini games much easier. Imagine if you have to like change small parameters within your mini games. You don't want to re-copy paste, right? So you create a function for it. It can get complicated, it can get messy, but it is very powerful. Recursion is a very powerful tool if utilized correctly. You don't always have to use it. Iteration or while loops, definitely viable. You can use this. But recursion is the advanced level concept that if you can utilize, if you know when to utilize it, you will be a much happier man or woman or whoever you are.
What?
Okay. Other than that, I hope you enjoyed this lesson. and go ahead and start making your calculator project after this one.